increase throughputs and follow compliances continue to rise. So that's where Heidoff can step in and present some of the right tools to really make a difference in the lab here. When equipment is designed for safety, consistency, automation, it doesn't just support your workflow, but it's going to transform it. So during this session today, we're going to explore, what those transformations looks like. We're going to highlight some proven areas where labs are commonly essentially losing efficiency, and more importantly, how to increase that real world impact of upgrading these technologies, such as rotary evaporators, advanced hot plates, parallel synthesis workstations, jacketed reactors, and different other solutions such as automated workstations. And these types of solutions aren't just going to incrementally improve, but it's going to create a catalyst that helps scientists reclaim time, reduce risks, and essentially improve data quality and increase safety here. So the goal here for today is simple. It's to give everyone a practical, actionable insight into how small changes within the equipment strategy can create major gains in throughput, reproducibility, and just overall lab performance here today. So just wanted to give a quick shout out. Thank you, Mass Bio, for having us today. And also thank you, Fisher Scientific, for having a great partnership and making this morning's webinar happen here. So that being said, let's get started. I just wanted to introduce myself. My name is Kyle Garcia. I am the National Sales Manager for Heidoff North America, particularly focusing on the benchtop tools. We also have Nate Kunze here today with Heidoff North America. He is our product specialist, specializing in a lot of evaporation applications, but also many different types of synthesis applications here today. And as we proceed through this webinar, we're going to have a little bit of a dialogue. We're going to have a little bit of a simple role play where my role is going to be a lab manager, where maybe when I am having different types of problems and situations in the labs that we need fixed. And Nate's going to come in and act as his natural role as a specialist to provide some integrated solutions and how to improve maybe some of the issues that I'm currently facing in my hypothetical lab that I'm facing today. So just a little bit of a run through of the agenda today. Again, just talking about our 4 real world bottlenecks that we see on an everyday basis, provide some solutions on what those problems, how those problems can be solved. And also have given Nate a chance to kind of demonstrate some of these products at the very end, just to kind of show you what these new products look like, and then talk about a little bit about how Heidoff can support you in the lab with different types of post-purchase support and just that overall high quality support that we can provide to you. And then we will also open it up to questions and answers at the end here. So for those tuning in on LinkedIn and YouTube, please feel free to throw your questions in the chat and we'll make sure to have those answered to you as quickly as possible. So partnering with Heidoff, we're recognized as a German quality manufacturing equipment manufacturer specializing in lab equipment. So a lot of our bread and butter equipment is going to be found in a lot of different types of research and discovery labs out there. So we are going to be very well recognized for different type of wet lab chemistry equipment. But we also have a lot of different types of solutions, as well as equipment for different types of life science equipment, as well as different types of scaling up project within the process development and even small scale production lines here. As a tier 1 supplier for Fisher Scientific, Heidoff is recognized to essentially provide the best pricings through Fisher, which is, again, with the partnership of Fisher Scientific, there's a lot of great benefits of working through that distribution channel, as our partnership with them is tied very closely here. But as you can see on the far left-hand side, this is going to be some of our lab essential products, such as hot plates and rotary evaporator systems and parallel workstations. As we scale up, a lot of different types of jacketed reactors and overall process solutions to essentially automate these workflows as we, continue to scale up into that small scale production stage here. And as you can see, we are one of the only tier 1 suppliers for Fisher Scientific to essentially provide these solutions. from small scale all the way up to production stage here. So again, Nate and I are very excited to essentially, talk about some of these solutions and how we can create better efficiencies in the lab today. This is just a simple workflow chart, essentially on where our equipment lies within the general workflow of what researchers are doing on a daily basis here. So as you can see, and as I've mentioned here today, a lot of our products are going to be supported within that synthesis and evaporation and that separation stage within the workflow here too. So just figure this would be a great representation on any types of end users or any types of your end users that are within this workflow here. We are more than happy to provide some efficient solutions that we will be talking about today. So as I mentioned, when it comes to different types of bottlenecks, these are some very common, essentially situations and problems that we are helping end users deal with on a daily basis here. And so we just took the time to point out 4 of these different types of problems and what we can do to help make your lab a safer and more efficient space for work here. So the first one that we'll be talking about today is going to be, any type of time sensitive situations. Obviously, we only have so many hours in a working day to get all of our work done. And so what can we do to help when it comes to making sure we have the highest efficiencies when it comes to any type of time sensitive processes that you all are dealing with on a daily basis? The second one is a very common one as well too. I mean, as we start to grow labs, as we start to increase headcount and labor, benchtop space is always going to be a critical component. And it's not just from, fitting a bunch of equipment on the tabletop space, but also it could potentially affect safety as well. So we have a lot of great solutions and essentially how to save space within the fume hoods and whatnot. So again, this is a very common problem that we do see on a daily basis here. The third one is just going to be some inconsistent experimental conditions. How do we create reproducible results in the lab? So we do have some software as well as some additional hardware equipment to essentially be able to create fluently reproducible results in the lab. And the last one is always going to be the biggest concern for all researchers in the lab is how do we maximize safety in the lab? Again, with our products, with our German quality, with our high quality equipment, this is something that we take very seriously. And we will be able to kind of dive more so into maybe some hypothetical or real world situations which have happened in the past in laboratories and how we're doing and what we're doing to fix those types of situations. So the first example, the first problem that I have as my position, as a hypothetical lab manager here at Heidel Pharmaceuticals. The first example, like I mentioned, is there's not as much time in the day for some of these researchers to perfectly perform some of their research being done here. So my first example that I have for you, Nate, is going to be when it comes to synthesis, when it comes to my hot plate reactions. I mean, some of my reactions that my researchers are doing are taking anywhere between hours to days here. And what that requires is a lot of, manual labor when it comes to just simply making sure that these reactions are performing as expectations, that there's not any type of exothermic or endothermic reactions going on here. But it just creates a lot of time-sensitive labor to simply just monitor some of my, basic reactions and whatnot. And it's difficult to sometimes run overnight reactions because maybe there's some safety constraints behind it there. So if there are any pieces of equipment out there that can help, simply save time and whatnot, so within my synthesis reactions, that would be great. Additionally, too, when it comes to evaporation, there's a lot of situations where sometimes our chemists, sometimes our end users are losing solvent throughout the evaporation process here. There's also this concept where our end users are going through a lot of foaming, a lot of bumping, a lot of lack of control when it comes to vacuum pressure within our rotary evaporator systems here. So if there was a way to simply automate, some of my evaporation process to essentially create higher efficiencies to efficiently pull off and recover a lot of my sample. That would be great too. So additionally too, when it comes to limited throughput, I only have so many rotovats for so many end users. So, and that being said, there is a case for limited throughput in the lab where it does take forever to not just run these reactions, but also exchange the solutions, exchange our solvents from flask A to flask B and whatnot too. And I want to just minimize the amount of flask handling going on within my process here. So again, here's just quite a few different types of situations when it comes into time sensitive situations. So Nate was curious to see what different types of solutions that you have for that.
Absolutely. And those are some very common problems that we get in the lab all the time. So first, starting off with some of your synthesis reactions. Most of the time in the R&D world, these will be done on a hot plate and will require continuous monitoring to make sure that you're not getting any overbubbling or any kind of runaway heating or anything in that kind of world. So we've designed our hot plates to be usable over long lengths of time, whether that be overnight or even throughout the entire week, through a couple continuous operation methodologies, and those will include things like safety sensors within the temperature probe and the hot plate itself, just to make sure that you're not getting any kind of chemistry that's going outside of spec that would require a safety shutoff, basically so that you can have that ease of mind of running this overnight. And to kind of go along with that, on our more simple end of the hot plates, we have automatic timer shutoffs. So if you need your reaction to only run for 8 hours, but you're going to be either out of the office or running that overnight, and you need to shut off after a specific amount of time, you can actually set the hot plate to shut off after that predetermined amount of time. With that, you can also have it continue stirring or cut off stirring as well, depending on what is the safest for your chemistry. On the higher end, you can even do some pre-programmable ramps in the event that you have a multi-step synthesis process. Maybe you need it to spin at such and such speed for an hour and then ramp up to a faster speed over time because maybe viscosity lowers or raises over the course of an experiment. Likewise for the temperature, if you needed to ramp up slowly or to do a slow crash down, sure, there's no active cooling, but you can control the way that it'll cool down using ambient air. That can all be done as well. So you can be doing not just more complex chemistry, but doing more complex chemistry without having to be around the plate, allowing you to just have a higher degree of flexibility and to be doing work that doesn't involve watching paint dry, so to speak. While that is very common on our hot plates, we also can provide that on things such as the overhead stirrers and reactors and other degrees of equipment that might be used at the scale for your synthesis reactions. Moving on to the rotary evaporators, you mentioned bumping and foaming as an issue and potentially a limited amount of rotary evaporators for some given applications. So to start off with some of the bumping and foaming, along with, again, kind of the attention required to use rotary evaporators, we have this solution called dynamic auto accurate. Basically, it's just a fire and forget mode for your rotary evaporator. What will happen if you were to use this automated mode with our standard rotary evaporators is it'll just take control of the vacuum parameter of your system so that you do not have to know the different boiling points of your solvents. And it'll also detect spikes in evaporation to reduce pressure in the event of bumping and foaming. So this methodology is great for when you just don't want to have to spend that time, again, watching paint dry, watching the evaporation process happening without having to key in multiple different solvent boiling points or even parameters when you're working with maybe 10 different solvents and you don't want to have all of those locked. Now, you have that option in the event that you want to be more manual. You can save a wide preset of different solvents or do ramps on that system as well. But of course, for the average researcher, it's significantly more simple to just let automation do its job. Now, in the event that we have a process in the lab that maybe we have to split it over multiple rotary evaporators just because the volume is too high. I'm talking, in a benchtop scenario, even 20 to 30 liters can be a large amount of solvent to have to process. Common examples of this that I see in labs every day are chromatography. Those generally, just to get a few grams of material, can require anywhere from 10 to 30 liters of solvent. We actually have a couple methods to get more out of your rotary evaporator. Now, while your benchtop rotary evaporator might have a 5-liter flask on there, we can extend that process time either in a manual manner, such as using a valve that will use the internal vacuum of the unit to pull more material in as you go, which is very helpful in these highly solvent-heavy processes where we're not going to need to dump that evaporation flask because the amount of material that we're actually aiming for is small compared to the solvent we're processing. However, that is still a manual process, and while it works great, we actually have the ability to automate not just the evaporation process, like I mentioned with the dynamic auto accurate sensor, but the ability to completely automate all fluid transfer steps. And so what I mean by that is we're automating filling the evaporation flask, we're automating removing the solvent after it's been evaporated, and automating removing what's left in the evaporation flask. So if we have a 30-liter volume to work with, we can actually, again, just fire and forget and let it transfer all those solvents and liquids and all that for us while the evaporator is running in the background 24 hours a day for as long as we need to be able to process that material. So what we might have split over 5 rotary evaporators to do in 2 or 3 days, we can now do during 1 day and 1 overnight cycle without even having to touch the unit. So those are kind of the methodologies we have for not just making your synthesis a little bit more hands-free and time-freeing, but also for your rotary evaporation. So we have to observe it less and we can be more comfortable with the results.
Wow, that's great, Nate. I mean, the biggest thing that I take away from that is just more so of having confidence in our equipment, of just a simple set it and forget it type of situation where we can know that our reactions, that our evaporation processes are going to essentially do exactly what they need to do without that monitoring of that process, sitting right there in front of the fume hood or something like that. So it does allow us to potentially, free up some time, hit that timer function or hit that dystomatic feature onto the rotary evaporator system and essentially be able to multitask in the lab very safely and efficiently there. So that's
Absolutely.
fantastic.
And it's not just the ability to automate, but the ability to feel confident that you're going to get good results without having to observe.
Great, Nate. Appreciate that. So the next problem I have in the lab, and this is a very common one, and as you can see within some of these photos that we have, it naturally happens over time where we have a lot of different types of equipment, different types of solvent bottles, different types of tubing from our Schlenk lines and things like that, where I'm running out of space for my end users to essentially work in a safe environment and whatnot too. And essentially over time, with some of our older equipment, we're in the process of not having enough rotary evaporators and not having enough hot plates, for some of the volume of work that we are required to do. So obviously with the time concept of it, we need to really focus on what we're doing, but it's nearly impossible to increase productivity when we don't have that space in the lab here. So essentially what this has caused is, for our end users to, wait in line to, essentially use a rotary evaporator system or run a reaction within the fume hood and whatnot too. And so again, with some of our older equipment that's starting to run slowly, we are running into quite a few bottlenecks when it comes to just the overall availability of our equipment, but also just the space that we're working in, where we can't provide a simple one fume hood, one rotovap, one or few hot plates to one of our end users here. So sharing is caring at the end of the day, but at the same time, that is definitely creating a major bottleneck when it comes to just increasing productivity within our end users here. So Nate, curious to see what kind of products, what kind of solutions that you might have to help increase productivity, because essentially this is what what of our fume hoods look like, is that we have many different types of hot plates in the lab with different types of and essentially it requires a lot of different hot plates to be taken up. And so essentially we have on top of that, different types of oil baths and hot plates and heating mantles. And as you can see, I have about 4 or 5 hot plates that are taking up a lot of space. And not just from the space point of it, but it's also very labor intensive to set up all of these reactions all at the same time. So it's, setting up hot plate 1, setting up hot plate 2. Essentially, it's going to take, quite a few minutes, almost hours to essentially get these hot plates up and running. But at the same time, if I am running, similar reactions, they're all going to have maybe some inconsistencies with different types of variable heating, variable stirring, maybe something that can't really essentially be seen to the naked eye, but there are, essentially a lot of inconsistencies from either one side of the hood to the other or from hood to hood there. So again, it's, having different types of flow rates with my gas manifolds, potentially if I'm trying to create inert atmospheres. At the end of the day, the more space that I have, the harder it is to clean as well too. So this is a big pain point that I have because just with a lot of our end users, we have multiple hot plates within the lab here. So again, curious to see what kind of what kind of solutions that you have for me.
Absolutely. And while we have a couple of different solutions for this type of problem, the most common and most effective is going to be our carousel system. Uh, Given that most of the time we are doing chemistry that requires heating and magnetic stirring, there's no reason why we can't be doing more than one sample on the same hot plate, especially given the volumes that are typically done. And even in cases where we need inert conditions or we need reflux cooling, we've designed around that as well. And so what the carousel does is it allows us to do 6 flasks or 12 tubes of similar chemistry all in the same hot plate. So where we might have before been doing 6 separate heating mantle setups or 6 separate hot plate setups with a distillation apparatus or reflux and condensers, we can now do that all on one hot plate. Basically saving 6 times the space or 12 times the space, depending on what type of chemistry that we're doing. And like I mentioned, what's great about this system is that it allows us to do parallel chemistry in a much more efficient way. Think of it this way. When you have 6 separate hot plates, you have a higher degree of potential for confounding variables to affect your chemistry. Be that slight differences in temperature from one hot plate to the next, slightly different rotation speeds, the ambient temperature in the air being slightly different. Now, these might seem small, but we're really trying to maximize a percent yield or really go at these synthesis reactions to get an effective product. They can make the difference, especially with the amount of space that they're taking up. So what the carousel allows you to do is operate those 6 flasks or 12 tubes all on the same hot plate under the exact same temperature because it is an aluminum block with very good heat transfer from the plate to the block, getting the same exact rotation speed from that thanks to the secondary magnetic field of the hot plate under the same exact inert gas conditions with the same refluxing for those tubes or the flask, allowing you to reduce those confounding variables and truly be able to do your parallel studies of what kind of variables actually matter and not what ones you're worried about. So this will help you with faster iteration cycles for your R&D. It'll give you some more data point details and whatnot because now we can do more reactions on the same hot plate. Again, optimize our resources because it's much easier to observe these 12 reactions or these 6 reactions when it's on one plate than if you had them scattered amongst the same fume hood or multiple fume hoods. And by being able to do this faster, it's just going to make your chemistry overall better. And while I mentioned that the carousel is probably the most common use for space optimization and parallel chemistry boosting, we have another product from Maya 4, which we'll go into detail a bit later, which is kind of like a higher end version that allows you to do a few additional things. But for basic parallel chemistry, where we want to maximize space while also saving money, can't beat the carousel.
Oh, that's really interesting, Dan. I mean, essentially, you just have one single hot plate that can run anything between 6 to 12 different reactions. And I mean, you're saving already a ton of space versus 6 hot plates all in a row like that. Essentially, you're taking up all the
Absolutely.
fume. So that's very inefficient. A very efficient way to save space, but also create consistencies here, which essentially leads me on to my my next problem that I have that does go hand in hand with just overall footprint is that I am getting a lot of inconsistencies going on in the lab, and I'm having a tough time helping my end user diagnose these different types of issues. Granted, I do have all different types of hot plates, all different types of, overall just equipment from different manufacturers. And sometimes, a lot of the common issues are coming from those older hot plates or essentially maybe even those non-jacketed setups where there isn't a lot of efficient temperature control going on here. So I have a feeling that this is maybe one root cause of what is creating these inconsistencies here. But what's even more frustrating is that from a reproducibility standpoint here, it's almost impossible to find these external variables, if you will, to have all these controlled variables line up to each other and create these reproducible results as I want to scale up throughout the workflow here. So like I said, there's a lot of different types of batch to batch inconsistencies. It might be user dependent. It might be some external variable controls like I've mentioned here. So if there is just only a way to maybe create these reproducible results, potentially through software, we've mentioned timer functions already, but I'm again curious to see, like, when it comes to these, essentially multi-step processes, what can we do to automate this workflow a little bit more?
Absolutely, and those are some great questions. When it comes to the consistency within our experiments, there's two key factors that are going to really influence how reproducible our results are going to be. And that is going to be, the methodology and the physical equipment itself and the accuracy it can provide, along with our ability to accurately follow recipes. So starting with the actual equipment itself, it's important, for example, if we're doing a temperature-based reaction, to not just have heating, but to have cooling. This will allow us to stay at a very consistent temperature range in the event that we have an endothermic or exothermic reaction, for example, where we want to stop it from going over a certain temperature or from dropping below a temperature. Thanks to active heating and cooling, we can very accurately push and pull our temperature at our exact level, along with using more insulated equipment so that we're not as affected by temperature outside. On top of that, you're going to want consistent stirring to make sure that everything is homogeneous within the sample, along with just some other outside kind of experimental safety conditions like over temperature limits and PID controls that are just going to help control that temperature, stirring, and other aspects of our experiment to stay directly on the settings that we want. Now, on that second end, we're going to have the recipes themselves. Following the recipe in the most exact manner possible is the second way that we're going to achieve those very consistent results. Because even if our equipment will perfectly put us where we tell it to, if we're inputting the wrong recipe, that could lead to disaster in reproducibility. So this is where software really comes into play. By being able to pre-program our entire run, we can ensure that those same parameters are used in the exact same way in combination with very accurate equipment to make sure our recipe turns out the exact same way every single time. So if either A, we were in production and we want to make sure we have consistent batches all the way through, we can do so. Or B, if we're doing percent yield experimentation to try and figure out what we can add or remove to boost up that yield, we can do that without having to worry about any other conditions being affected. And so that can be done with our Maya system that I mentioned earlier, active heating, active cooling in 4 workstations. It's almost like a carousel, but built around the ability to heat, cool, reflux, and overhead stir or magnetic stir all in one station, or through our reactor systems that you see on the right here. You combine that with Maya software or Ava software, which basically lets you design all your recipes, set up specific PIDs, or whatever kinds of additions, subtractions, other pieces of equipment that you need to be built around it, all amongst a long time schedule for the entirety of your experiment with good data logging and reporting afterwards. So you don't just do a consistent experiment every time, but you get the data log results so you can review and make sure everything did in fact turn out accurately. We also have a high process system, which will allow you to do the same things, whether it's with reactors or evaporators, hot plates, or other pieces of equipment. So as kind of a summary of why that matters, it allows you to run your experiments in a more consistent fashion, thanks to both accurate equipment with good temperature control and automation or software that allows us to follow those recipes more exactly. It removes the variability from having to manually adjust parameters yourself. And most importantly, harping back on this, it frees the experimenter from having to be there for this portion. These synthesis reactions, they can last anywhere from 2 hours to 2 weeks. And nobody wants to dedicate their resources to just watching that happen. Sure, it might be good to observe a couple key conditions, but you can even build those into the schedule of when an operator should be there to observe a color change or anything like that. So it's very important to have these kind of methodologies to not just increase consistency, but to free up your operators. And as I mentioned before, with the data integrity aspect, being able to data log all of that so you have something to review, maybe in a GMP environment or anything of that sort of nature where you just want to have accountability, you have that ability as well.
This is great, Nate. And you mentioned a few things within this solution here is that, within these reaction stations, we're not only producing heating, but we're also producing cooling. I think that is essentially very important when, again, you mentioned when we're dealing with exothermic, endothermic, or just any other type of controlled reactions here, because even though, for example, we might be heating to 100 degrees Celsius, for example, there is still going to be some sort of, overshoot going on no matter how precise your hot plate is going to be here. And so with that process and methodology of throwing in some active cooling within that reaction here, you're essentially going to minimize and essentially prevent any types of overshoots from taking place here too. And essentially, when it comes to reproducibilities, the way I envision this to be set up is like you have all these different types of profiles within a library, and it's just simply click that profile, upload it to the software screen, hit start, and it's going to be exactly what that equipment is going to need to do. Same thing as last time to again create those reproducibilities. And essentially, this is just a very time a time saving solution as well. So very very important to essentially implement software if we do get into the process of scaling up our reactions here.
Absolutely.
Now, this is a really important one to me. I mean, as the lab manager of Heidolf Pharmaceuticals, that's my main job is to make sure not just the building is safe, but to make sure our end users are safe here. And I've seen many different types of horror stories in the past where we do have equipment that has some types of worst case scenarios in a way where I've seen hot plates catch on fire due to any type of like overheating situations, again during these unattended operations. So I need a lot of faith and I need a lot of confidence that these pieces of equipment are going to do exactly what they need to do. But if there ever is a case of maybe a severe situation, what can my equipment do to maximize the protection, maximize the safety of the operator within this? Again, with different types of chemicals, all over the laboratory here, there's going to be accidents happening. There might be some spills leading to any types of, again, overheating situations. I even have had maybe some potential thermocoupling malfunctions happen in the past with some of our older hot plates. But essentially, again, also create lack of feedback when it comes to these precise temperature controls and whatnot too. And so again, like I've mentioned with a lot of our older equipment, we might not have some of this higher end technology. And as always, cost versus value is always going to be, a concern for me. So I want to make sure I pay for what I get at the end of the day. But again, with these types of situations, it's just naturally, unfortunately, there are a lot of situations where hot plates catch on fire, or even labs are flooded from the overuse of water overnight and things like that too. So again, Nate, I need to make sure that all of our equipment is really drilling down the safety aspect of it. So I'm curious to know and understand how some of the Heidolf equipment is focusing on some of those areas here, because as you can see, again, with different types of runaway temperatures with some of our hot plates here, we do a lot of refluxing in our lab too, which is just a simple condenser that you connect to the top of our round bottom flask here. But we do use a lot of house water, so that's not only wasting water, but like I said, overnight sometimes our water pressure does fluctuate a little bit. When we have had some situations where potentially some water lines have accidentally disconnected from some of our condensers, doing some of these overnight reactions, come in the next morning and we see quite a few feet of water in the lab, and that's never a happy situation or anything like that. Again, like I mentioned too, we do use oil baths in the lab. And like I've mentioned as well, there have been some situations of splashings and spills and whatnot. And, cleaning up oil is never, a pleasant experience, even at room temperature, but, especially when it's hot, it creates very, very high risks of just overall safety and whatnot too. So, I'm curious to see again what kind of substitutions are out there on the market and what Hide Off can do to help me out with some of these, reoccurring situations.
Absolutely. And I'm going to start off with saying that safe hot plate chemistry is going to start with the safe hot plate. And that's something that we really take to heart with our hot plate system. We have a die-cast aluminum housing to protect it from any spills that might happen. That way you don't get anything that starts from the hot plate itself. And another feature that I'm really proud about is our 2 independent safety circuits. That's basically just a fancy way of saying that there's an independent sensor cutoff within the temperature sensor itself and the temperature sensor in the hot plate. So if whatever material that we're heating happens to run out of spec due to a runaway reaction or just a standard endothermic, exothermic kind of deal, the system will go into a safe state that cuts heating and allows rotation to continue so that we can stay safe in that manner. This has been absolutely helpful with reducing or pretty much eliminating the risk of fires happening in the lab started from the hot plate itself. Now, when it comes to those water lines, that can get really tricky. We have both dripping onto hot plates themselves or, full on leaks, or even just condensation on those condensers that can drip into an oil bath and lead to splashing and splattering that can be dangerous in the lab. So instead of trying to design a safer condenser, we thought, let's just remove that water aspect entirely. And because most synthesis refluxing chemistry is done hot, we were able to use an air condenser known as our findenser to be able to successfully and actually very efficiently reflux a large range of different solvents, completely eliminating the need for a water condenser in your lab, period. Basically, it's got aluminum fins and tentacles inside of that condenser itself that will apply heat transfer to any of the vapors that come off in the reflux reaction. And just the ambient air in the lab will provide that cooling, because most of these solvents at reflux temperatures are boiling above the 50, 60, 70 degree Celsius range, in which case we have a very large delta T in terms of what we need to be to recondense that back into a liquid. And then we have the heat on block, which completely removes the need for an oil bath. These blocks are designed in a way to allow you to do a wide range of round bottom flasks without the worry of the flask becoming enclosed or cracking due to thermal expansion of the glass and the metal. They're designed so that even at high temperatures, they won't expand into themselves and lead to cracking of the flask like some other plates might. And by being able to completely remove that oil bath aspect, which can be very dangerous, we lead to a much safer lab. Some of the biggest problems I personally see with oil baths are just the splattering that can occur at the high temperatures, but even more so, the flash point of oil actually degrades and reduces over the course of weeks, months, years without it being replaced. The oil bath actually has like a best by date or an expiration date on it. And if you keep that oil in that bath for too long, what might, typically ignite at 450 degrees Celsius is now creeping down, igniting at 300, igniting at 260, until it finally gets into the range of, 100 to 200, where it might actually ignite during typical experimental conditions. So removing that oil and not having to worry about the maintenance and the mess of replacing that oil bath in general is just very, it provides peace of mind. And when you combine a hot plate like this, the heat on block and the condenser, not only do you have a very, very safe package, but one that uses less resources, no oil, no water. So basically reducing costs, paying for itself within a very short time of the lifespan of the products, or compared to the lifespan of the products. And it's also a bit of a space saver. We're not tied down to tubes for the condenser. We're not tied down to places where the oil is required to be kept within to reduce the mess. So it's very flexible. And to kind of quote one of our end users that was very happy with this product, they were able to undertake a campus-wide initiative to reduce energy, water consumption, and the condenser is perfect in drought-stricken California. So it's good to see that people have been really benefiting, not just from the safety aspects, but the economical and the environmental aspects of equipment like this. And so, to kind of satisfy for that, or to summarize for that, we're basically just looking to minimize accidents, lowering the liability. We don't have to worry as much about the insurance claims or the insurance prices of preventing lab flooding from things like this. Provides a safer, cleaner environment for our employees, making them happier to work with these products. And, we're reducing costs over the lifespan of the unit, but also because there's less errors that could be happening just due to the nature of oil baths and water condensers. So it really provides a nice clean package for increasing safety, but also generally increasing the enjoyability of using these products.
I mean, these are very simple concepts here, and I've never even really thought about these types of technology, such as like a condenser, heat on block in the lab here. But from a cost effective standpoint, I would imagine it's somewhat similar, or nothing too detrimental, to compare to some of our traditional methods and whatnot. So, again, very simple accessories, if you will, when it comes to our hot plates. But even when it comes to our hot plates, like Nate mentioned here, we have fire resistant aluminum die cast housing, and our hot plate is also backed up, I believe, Nate, by a 10-year warranty as well, too.
Absolutely.
So just the overall longevity of these hot plates are built to last, as well with some of the most durable material that you can put on a hot plate on the market here. So that goes a long ways, not just from the durability and the quality standpoint, but also from the post-purchase support. When it comes to that 10-year warranty on our hot plates, which is fantastic to know that I'm, fully safe and protected with some of those items there. So let's dive into a little bit of the, of a cost versus value situation as we, essentially wrap all of this up here, because obviously with a lot of these products and a lot of these solutions that we've talked about today, time is money. But at the same time, sometimes there's difficult situations to make investments in today's economic environment here. But, the most important part of this, initiative and investment is, finding ways to modernize laboratories with modern equipment. And once we do have those, values to modernize some of our equipment, it's going to significantly decrease the amount of consistencies when it comes to repairing maybe some older equipment. Essentially, when it comes to replacing spare parts, again, especially with some of the older equipment, there are a lot of situations where some of those items have been discontinued, and it makes it very difficult to find replacement parts. And if and when we do have a tough time finding replacement parts, then we're in a very tough situation on what to do next when it comes to maintaining some of our equipment here. Again, when it comes to wasted samples, if we are finding situations where we ruin an experiment or something like that, and that failed run is going to essentially cost time and money at the end of the day. So the overall concept is having older equipment is going to essentially equivalent to higher failure rates and essentially wasting money as well too. So that comes to the challenge of identifying that threshold of when is it time to upgrade my equipment and when is it time to make those investments here. Within this slide we have just a very hypothetical cost equation, if you will, when it comes to just talking about hot plates here. And so what we've written up is just what does value mean? And so the value is essentially all the productivity gains that we have had within our experiments, avoiding costs such as failed runs at the end of the day, but more importantly reducing risks, not just from a sense of cost but also from a sense of safety, like we've mentioned too. We tie that all in, and what's the cost of ownership look like at the end of the day here? So throwing this hypothetical scenario here, if we do have quite a few outdated hot plates, and let's just say there are 2 failed reactions per month, and maybe those reactions are costing $400 in overall materials as well as labor. You add that up to a yearly basis here, and we're looking at about $9,600 of wasted money, wasted time per year. So that's pretty simple to justify the cost of just even upgrading to new hot plates here. Hypothetically, say some of these hot plates might be costing $1,000 to $1,200 here, but we can significantly reduce some of those risks, some of those failed reactions here. 80% even on the conservative side here with some of our newer hot plates. I would probably put this even closer to 95 to 100% of preventing some of those failure rates here. So you kind of add that up here, and essentially you're going to find yourself paying off those failed reactions in the span of 2 months. So again, it's just a simple concept of value equations, tying in when is it important to justify upgrading your equipment, and it's I challenge everyone to just reflect on where can we save costs by investing in equipment, and not just by investing in equipment, but also increasing the safety, the productivity, and just the overall efficiencies in the lab today that we've discussed here. So moving on here too, these are some of the products that we have discussed today. And I know Nate has a quick little, visual within our Chicago headquarters right now. So again, talking with some of our automated evaporators, and as well as some of our software. Even though that might be a little difficult to demonstrate today, we do have a lot of these products and equipment available for demonstrations if you were interested in learning more about how to automate some of that evaporation, and how to increase throughput, not just within the automatic distomatic system, but also within our high process and AVA software on integrating some of our equipment here. But more importantly, Nate, I just wanted to bounce it over to you, just maybe potentially showing, the carousel system and some of those concepts really quickly.
Absolutely. And since we talked about the carousel quite a bit, I thought it would be a great example for us to just do a little live from the lab so you can see it yourself. So I hope you guys can see this all right. Yep. What I have in front of me is one of our hot plates, along with the Carousel 6 system and the Carousel 12 system, both allowing you to do parallel chemistry on a smaller footprint, with the ability to do both tubes or flex, depending on what is necessary. What's really neat about these 2 pieces of equipment, as I mentioned earlier, is that you get very consistent heating between all of the different reactions on the plates. But what's neat is you also get very consistent stirring, and I kind of wanted to demonstrate that right now. So on a hot plate, you get really nice consistent stirring in the middle of the hot plate. As you kind of move away, it gets really wonky. But there's actually this secondary magnetic field around the hot plate where you get really nice consistent stirring again. And that's what the carousel takes advantage of in order to give you that consistent stirring. So now our parallel chemistry is going to have very consistent heating, very consistent magnetic stirring, along with inert gas capabilities and refluxing, so that we can eliminate as many of those confounding variables as possible and still have a nice, efficient, space-saved reaction. So just kind of wanted to show that for you live so we can get off the PowerPoint for a little bit. I know it can get a little long. Thank you.
Thanks, Nate. Appreciate it. I mean, that's great. And essentially, if there are any other pieces of equipment or products of interest from anyone, please don't ever hesitate to reach out to us. Nate or even some of your local solution specialists out there are always more than happy to provide some more information and demonstrations of all and any of our equipment that we have within our portfolio. Now, pivoting a little bit here, on top of all of the high quality equipment that we have talked through today, Heidoff, we take a lot of pride in just the overall high quality post-purchase support that we can provide to you all. And, we have local sales specialists, particularly out in the Boston and the greater Jersey area. We're assuming, a lot of the audience is here today. But we also have solution specialists located all over North America to specifically support each and every one of you on a daily basis here. So a few just pillars essentially that I wanted to highlight is just emphasizing some of the health days that we can provide. And essentially, a health day is just a preventive maintenance check on any of our equipment. At the end of the day, who can say no to a free oil change? So what we do provide here is just to ensure that all of your spare parts, all of your seals, everything within your equipment is cleaned thoroughly and safely. Again, making sure any of your consumables within your equipment are fully functional and to simply maximize the lifespan of your equipment here. And so essentially we can arrange this on an annual basis. As I mentioned, we have a lot of locality when it comes to, how we support all of our laboratories and end users on a daily basis. So this is just a great benefit for all of our end users to take advantage of. And there is absolutely no, anything when it comes to extra costs or investments after you purchase, the equipment from Heidoff here. Additionally, too, we have a great trade-in promotion to enhance sustainability within all labs here. So this includes anything from, trading in any of your equipment from rotary evaporators, hot plates, older hot plates, things like that. We have a great resource to essentially have a process, to essentially recycle, older hot plates or older rotary evaporators, any of the equipment that we've talked about today in the lab here. And so on top of the trade-in, sustainability initiatives. We also provide a little bonus and including extra promotions and discounts to end users that are looking to perform some of these trade-ins and whatnot. So we partner with a company, with an organization called Seeding Labs, which is essentially, finding ways to present solutions in underprivileged labs worldwide. And this is just a fantastic partnership that we have done somewhat recently. And as you can see, that value within the last few months, we provided over $25,000 of lab equipment to, again, some of those underprivileged areas within the world here. On top of that, again, I've mentioned the post-purchase support that we provide here, and essentially we provide free labor for the entire lifespan of the product. So no matter if it's within that warranty plan or outside of that warranty plan, again, with that locality of some of our specialists, anytime you need, one of us to come on site for any types of consultations or post-purchase support, servicing, things like that, there's absolutely no such thing as servicing contracts. Again, the only initial investment that you need to make is going to be from the point of purchase of that new equipment. And after that, you're completely guaranteed to be in the best hands possible to make sure your labs are up and running safely here. Like I mentioned, we have a 10-year warranty on our hot plates, which is an industry-leading warranty out there. So, like I mentioned, our hot plates are built to last. And then also when it comes to our rotary evaporator systems and some of our other equipment, we provide a standard 3-year warranty on our pieces of equipment there. So, we have a full library of products and resources on our knowledge base. Again, with the help of Nate and myself, you guys are guaranteed to be in good hands and not just have high quality equipment, but have equipment that's going to be built to last at the end of the day there. So if you have any questions or any products of interest or anything like that at all, please don't ever hesitate. Like I mentioned, I am the sales manager for all of our benchtop equipment. But we also have a local solution specialist by the name of Adam Sink. He's based out of the greater Boston area. And as you can see within his territory is covering Connecticut, Rhode Island, Massachusetts, New Hampshire, Vermont, and Maine. But if you're not based out of that geographical area, feel free to scan that QR code or just reach out to me and I'll put you in contact with one of your dedicated solution specialists there. That being said, we love to open it up to any different types of questions out there that may be. So I would love to give it a few seconds here. And looks like we do have a few questions to address here, and we'll make sure to wrap this up here in the next few minutes. So First question that we have is, what is the best process to purchase equipment from Heidolf, and where can I receive the best discounts for these items? Which is a great question. I think I mentioned a little bit earlier in the beginning of our presentation here. So, like I mentioned, Heidolf has a very strong partnership with Fisher Scientific. I mentioned that Heidolf is considered a tier one vendor for Fisher Scientific. Essentially, what that means to you all is that we are contracted to present the best pricings on the market through the Fisher Scientific channel. And then on top of that, Fisher Scientific does a fantastic job making sure, shipping is covered, making sure that you guys are taken care of when it does come to maybe additional, items or equipment, consumables, things like that. They're a fantastic one-stop shop to essentially provide solutions for anything within your laboratory equipment on a daily basis here. So with our strong partnership with Fisher, you're guaranteed to be provided the best equipment, best pricings, and the best of solutions at the end of the day. I have another question here. What volumes can your rotary evaporators go up to? Nate, this might be a great question for you.
Absolutely. That's a wonderful question. So while our benchtop rotary evaporator has up to a 5-liter flask and our industrial scale rotary evaporator has up to a 20-liter flask, with the Distomatic completely automating your system, you truly reach unlimited amounts of volume. And given that unlimited is probably too big of a term to use practically in our labs, I like to say the maximum volume of our rotary evaporators is the maximum volume of the container of which you fill with material that will eventually be rotary evaporated. So 55-gallon drums, 20-liter carboys, whatever it is, the rotary evaporator can handle it without you needing to interfere with the system itself.
I mean, yeah, that's great, Nate. Yeah, essentially, it's unlimited throughput for your
There you
evaporators
go.
at the end of the day. Very nice. Okay, looks like we got one more question here. So, is your equipment GMP compliant, and do I have the capabilities to data log? Nate, maybe you can take this one as well.
Yes, absolutely. So most of our equipment has the ability for data logging. That way, if you are in a GMP facility, for example, you do not have to do all that logging yourself. You can just pull the data, sign it off yourself there without too much of an issue. Past just the simple data logging that's on all of our equipment, we also have our automated methods, the AVA software or the high process, which can do an even higher degree of the data logging and enable some higher end and higher level software controls and data readouts that will generally benefit your process, whether it's GMP or just using it to reproduce SOPs or other recipes across this spectrum of experiments you're doing.
Perfect. Thanks. Appreciate it, Nate. Well, I think that's going to conclude our today's webinar. Thank you so much for everyone chiming in during this hopefully productive session. Again, if we didn't have a chance to answer your questions, if you have any additional requests or want to have any discussions, like I mentioned, we on top of the high quality products that we offer, we're also here to support you all, from start to finish here. So, we're really looking forward to continuing to grow with each and every one of you. Again, shout out to Mass Bio for having us on this presentation today. Shout out to Fisher Scientific for making this whole thing happen, and shout out to everyone on this webinar for making an impact in this scientific community. So appreciate each and every one of you for chiming in today. Hope you have a great rest of your day, and more importantly, happy holidays to all of you all. Thank you.
Thank you, everyone.